Good afternoon, everyone.
Good afternoon, sir.
Yes.
Good afternoon, sir.
Okay. So it's already 1:11 in the afternoon. We're going to continue our lecture that started yesterday. So by the way, for the first activity, for the five problems I've given you, I will still give you time to answer that one. I will just post an activity in our Google Classroom from which you will submit your answers. So we will be finishing the entire lecture for the preliminary topics. I believe I will be able to do that this week. So last lecture natin tomorrow so that I can give Friday as your activity time because there's another activity 2 for this preliminary chapter. So anyway, yesterday we had a brief introduction of what abstract algebra is. Nagbigay tayo ng brief history as to how the field was developed. And then we also provided the things that we will be learning under this course. So we mentioned that we will start with preliminary topics. These topics are related to the topics that are uh, under this course. So we started with the appreciation of mathematical proofs and we provided uh, a background for you to have an idea of how we really write mathematical. Today we will continue discussing some of the important preliminary topics. The first or the second one is on set and set notation because a lot of topics in abstract algebra we are actually talking about sets of numbers. Hindi naman kailangang numbers, set of positions and other sets like other objects, I mean. So I believe we provided the notion of a set. It's important in the description of a set that it's well defined, so we know whether a set is considered well defined or not well defined. For well defined sets, we mentioned that uh, an element must be entirely not included or entirely included in that set for that set to be considered well defined. Kasi kung hindi tayo sigurado, we do not have a basis or a criteria of saying 100% that an element or an object is an element of that set, then the set is not well defined. The word close to does not really uh, represent a well defined set. Okay, so some other set and set notations. So we know, of course, that we enclose the elements of that set by a pair of braces. So we do not just leave our elements without this. We have a term here, a definition actually, null or empty set. It's just a set with no element. We normally denote a null set by that Greek letter, that's phi, or we use an empty pair of braces. Take note that this is not a null set. This is a set containing the null set. So it's not actually a null set, the second one. So we either choose how we represent a null set. A unit set is a set containing one element. So isa lang ang element niya. So actually, this is an example of a unit set. Here are other examples. By the way, if you have questions on a particular slide, you may actually interrupt para hindi natin ma-skip. You can actually ask as we discuss. It's okay. Just get my attention and ask your question later on. Okay, so how do we represent again our set? Medyo bibilisan ko yung alam ko na medyo alam na natin. So there normally there are two methods of writing a set. First one is the roster method. So this is a way of writing a set by listing the elements of the set. And by the way, we name a set using a capital letter. If, di ba? That conventional way of writing or naming a set, it's by capital letters. Sometimes we use the Greek letter, but in this presentation, most of the examples of the sets that are used in the examples are named using the English alphabet. So we use the capital letter. Roster method, we list all the elements. So we see here that we have two examples of sets written in roster method, set A and set B. The other one is called the set builder method. So the examples here are the same set written in different methods. So these sets are actually the same. It's just that they are written in another ways. The set builder method. This is read as. How do we read this one? Set A is the collection or the set of all x such that x is a day in a week. Similarly, set B is a set of all x such that x is a lowercase letter of the English alphabet. When is it appropriate to use roster method and when is it appropriate to use the set builder method? So normally roster method are used for sets that are first finite. Syempre finite dapat yan para malist talaga natin yung elements and konti. Yeah, kagaya nito. Kahit kasi finite din yan kung madami, like for example 1,000, 500, 100, then it's really cumbersome to use the roster method. Nakakapagod magsulat ng mga elements. We resort to the set builder method if that's the case. For infinite sets or for finite sets with a lot of elements, the set builder method is way better. It's easier to use. All right, so we're going to discuss now the set of real numbers or the real number system. So we are still talking about sets, but we are now on focusing on the set of numbers. Hindi lang siya basta kung ano-anong set. Also, I included this one so that we get familiar also with the notations that we will be using. So, of course, there is a hierarchical relationship of the different sets. We're going to discuss that also. So we start with the positive integers, sometimes called as the natural numbers or the counting numbers. And these are the symbols that we use. So these are not entirely letter N. So parang may ganyan yan. Minsan, yung pag-drawing nila ng symbol na ito, yung parang bold na part ay yung dito yung first na vertical line. Pero dito kasi yan, yung naka-diagonal. That's natural numbers. Or if you use zeta, lagyan lang natin ng superscript na positive to denote that it's not all the integers. We are only talking about the positive integers. Now, this is a set. This is a unit set containing the element, the number 0. If we combine or take the union of these two sets here, we now have the set of whole numbers. We denote that by W. So we see there that the only difference in terms of the elements of the natural numbers in the whole set of whole numbers is the element 0. So walang 0 sa natural number. That's why we call it counting numbers. We start at 1. We count at 1, starting with the number 1. Okay. So, ang counterpart ng positive integers ay malamang yung negative integers. That's why our notation is the same letter, the same symbol, it's zeta. Ang kaniyang superscript ay the negative sign. This denotes the negative integer. So we start from negative 1, negative 2, negative 3, and so on, so forth. Integers lang sila. If we take the union, then union na yung tinatawag natin na set of integers. So it includes the negative ones, 0, and the positive ones, integers. Fractions is a different set of numbers. Nakahiwalay siya. What are fractions? We know what are fractions. So that when we take the union of all the integers and all the fractions, the resulting set is called the set of rational numbers. The word ratio, ano ibig sabihin ng ratio? It's a comparison of two numbers. So the roughly a rational number is anything that can be expressed as a ratio of two integers, a and b. B is not of course equal to 0. So if a number can be expressed that way, quotient, di ba? Then that is considered a rational number. 0.33333 and so on and so forth, that is a decimal number. That is considered a rational number because that number is can be written as a ratio of two numbers. So yung 0.3333 na yon, that is actually equal to 1 over 3. So 1 and 3 are elements of the set of integers. Na-express natin yung decimal na yon as a ratio of two numbers. Therefore, it's considered a rational number. So normally, yung mga repeating decimals natin, pero non-terminating, they are rational numbers. The opposite, so if a number is not rational, then it is irrational. So yung definition natin is the negation for the definition of a rational number. These are numbers that cannot be expressed as a ratio of two numbers. The classic examples for this type of numbers, we have our number pi, which is roughly 3.1415. Yung pi natin. Or we have Euler's number, that's E, roughly equal to 2.72. That's E. Square root of 2 is also an example of an irrational number, square root of 3. Marami tayong irrational numbers na radical numbers. And finally, of course, if you take the union of these two types of numbers, sets of numbers, then we have real numbers. In this course though, majority of the course, ang pinag-uusapan lang natin na numbers ay ito, real numbers in all of its subset. Although, of course, there's a part of this course that we will be discussing. I'm not sure if maabutan natin topics that involve the complex numbers. Ang susunod dito, meron tayong number I that's equal to the square root of negative 1. And if we combine a real number to the imaginary numbers, then we have our complex numbers in the form of a plus bi. A and B element of the set of real numbers. Pero for now, we consider muna any of the set of real numbers and any of its subsets. So bali, subsets lahat ito ni set of real numbers. So in the coming slides, kapag hindi siya real number, normally nakafocus tayo sa positive integers, negative integers, and positive integers. Doon tayo nakafocus or the whole numbers. Not so much on fractions and irrational, but it's not impossible na gagamitin natin sila or they will be involved in future lectures. Okay, let's compare finite and infinite sets. What are finite sets? Yung nabibilang. A set whose number of elements is a whole number. So kung bibilangin natin yung number of elements ng isang finite set, it should be any of the numbers sa set of the whole numbers. So actually, pwedeng 0, pwedeng 1, pwedeng 2, pwedeng 3, and so on, so forth. That number is called the cardinality of a set. So it is finite if the cardinality of that particular set is an element of the set of whole numbers. By cardinality, we mean the number of elements in the set, denoted by this symbol. So we use the absolute value, no? Absolute value symbol. X is the given set. Ay, bakit X ito? Dapat E ito. This should be A, denoted by the absolute value of A. Example, pati ito mali. This is supposed to be the cardinality of A. So why 4? Because obviously there are 4 elements in set A. That's an example of finite set. Infinite set, medyo uh, highfalutin yung definition, but we can actually understand this one. A set of elements of S is said to be infinite if the elements of a proper subset S prime. So what is S prime? This is a proper subset. We haven't discussed yet the definition of a subset, but I'm sure now you know what a subset is. So S prime is a subset of S, and that subset can be put into one-to-one correspondence with the elements of S. Ano ba ibig sabihin ng one-to-one correspondence? We can actually match lahat ng elements sa S. Meron silang pair, no? Pairing sa S prime. And remember that S prime is a proper subset of S. Let us try to illustrate that one by looking at some examples. But before that pala, we talk muna about the difference between equal and equivalent sets. Equal sets, so set A and B are equal if, denoted by the equal sign, if and only if A and B have exactly the same elements, regardless of course of the order. And they are only equivalent if the two sets have the same cardinality. Okay, I have questions here before we proceed to the specific examples. Let us try to answer this one. Let us use our chat box. The first question is, if two sets are equivalent, must they also be equal? True or false? Everyone, kindly type your answers. True or false lang ito. If two sets are equivalent, must they also be equal? What do you think? True or false? Yes, false. Tama. That's actually correct. Yes, false. We are talking still about the first statement. Well, of course, two sets are equivalent. Ang tinitignan na natin ay cardinality. So, maaaring number yung the set of numbers yung isang set, the set of letters yung isang set. Pero kung parehas naman sila ng number of elements, then they are still equivalent, but of course, not equal. How about this? If two sets are equal, that's the hypothesis, then they are also equivalent. Is this true or false? Okay, tama. True. This is a true statement. Okay, I have prepared here some statements, and we're going to identify whether they are equal. So, pair of sets ang ibibigay ko. Sabihin ninyo kung equal, equivalent, or neither. Kasi alam natin na kung equal, equivalent, ang sagot lang natin dun ay equal. Pero kung equivalent but not equal, ang sagot natin ay equivalent. So, equivalent only. And if neither, not equal, nor equivalent, we answer neither. Let's us again use our chat box to provide our answers and then we discuss. Okay, the first pair of sets, we have the set containing A, E, I, O, U, or the vowels of the English alphabet. The second set contains numbers 3, 7, 11, 15, 19. Equal, equivalent, neither. Okay? Tama. That's this is an example of an equivalent set. Well, obviously, letters nga dyan, tapos numbers dito, they can never be equal. So, ang possibility lang dito ay kung equivalent sila. So, we simply count the number of elements. 5 dito. So, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 din sa isang set. So, they are indeed equivalent. Another pair of numbers. Number 2 na tayo. Equal, equivalent, or neither. Okay? That is again true, neither. Will obviously 4 dyan, 3 dito. So, hindi na natin i-check yung equality kasi hindi na sila equivalent. So, neither. Tama.
You're right.
Okay. Sige. Number 3. Let me read the sets. So, the first set is a set of all x such that x is an element of the set of whole numbers and at the same time, x is less than or equal to 5. Equal, equivalent, or neither. Neither. How about the others? Sabi ni Ma'am Kanja, it's neither. How about the other two? Neither din si Ma'am Suposo. Mhm. Sige. Ano ba ang mga elements if we are to write this set in roster using the roster method? Ano ba yung mga laman? So X, if we're going to list the elements, nakaset builder ang pagkakasulat. Set na yun. If we're going to write it using the roster method, saan ba tayo magsisimula? Ano yung elements nito? Ano yung mga laman? Ano yung laman? It's 0 because it's a whole number. We start from 0. But it has to be less than or equal to 5. So 0 to 5. 0, 1, 2, 3, 4, 5. So if we count the number of elements here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Kaya neither. Tama. Alright. Let's have another one, another pair. 5, 10, 15, 20, 25, 30 until 80. So we know what this notation mean. There are numbers there in between. We just did not write it. And then we have another set, the set of all x, such that x is an element of the set of natural numbers. At the same time, x is less than 17. So are they equal, equivalent, or neither? What do you think? Ano ba ang laman nito? It's a number, a natural number, so we start from 1. Well, 1 is immediately not an element of this set, so they can never be equal. The question is, are they equivalent? So we need to count the number of elements of the sets. So first, ilan ba ang elements dito? If we look at it, these are natural numbers divisible by 5. Naka-multiple siya ng 5. So to count the number of elements there, we simply divide 80 divided by 5. Ano ba ang 80 divided by 5? 16?
16, sir.
Okay,
16.
16. And then how about the other set? If we start
16
from
also.
1, yes, if we start from 1 and it has to be less than 17, then we stop at 16. So 16 elements then. They are equivalent. Of course not equal. Number 5, kitang-kita, kaya mabilis lang. Equal, yes, tama. Okay. Let's now talk about pairs of sets. Pero ang set natin ay infinite. Ganun pa rin yung instruction. We're going to identify whether they are equal, equivalent, or neither. The two sets are the two given sets there. What is this? This is the set of all integers. So negative 1, negative 2, negative 3, kasama ang 0, kasama yung positive 1, positive 2, positive 3, that will extend to both infinities, positive and negative infinities. Now, we can actually rule out that the two sets are equal because, well, of course, we cannot find negative numbers in the set of positive integers, so they can never be equal. The question is, how about their cardinality? Kasi nga, 'di ba? That will tell us kung equivalent sila or hindi. So the question is, how many elements ang nandito and how about sa isang set na ito? What do you think? What do you think? The two sets have the same cardinality or no?
Sir, hello po sir.
Yes.
Sir, kwan po ba parang considered neither? Hindi ko, di ko pala sure. Sorry.
Bakit neither kaya? It's okay. We just want to know your reasons.
Sir, wala. Sir, ang inisip ko po kasi is yung parang for the real number, it's negative infinity to positive infinity. Pero dun sa positive integers, parang positive infinity lang.
So, one set is bigger or has more than elements. Pero positive integers lang yan at saka integers ang kino-compare natin. Alin set dyan ang may mas maraming elements?
Sir, C. Tama yun. Z is real number. Integers, sir. The whole integers.
Okay. So, let's discuss this one. So, what I'm going to do here, that's not a question mark, but a pair of close parentheses dapat yan. Sorry. Bakit question mark yun? So, this is the set of integers. Tama ba? It includes 0. Siyempre, nandyan yung 0. Tapos yung positive numbers. 1, 2, 3, 4, 5. And then the negative numbers as well. We have negative 1, negative 2, negative 3. That will continue. Normally, ang pagkasulat natin dito, andito yung mga negative numbers. And then sa right side ng 0 ay mga positive numbers. But we can actually do it this way also. Now, I'm going to compare it with the number of elements na meron doon lang sa set of positive integers. And what is that set? Ano yung set of positive integers? This includes numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, we can see na lahat ng numbers dito pwede kong ipares. Pwede kong bigyan ng pair from the set of positive integers without leaving an element in any of the sets without a pair. Do you believe that we can do that? That is, all elements here will have a pair in the set of positive integers. So walang element in any of the sets ang mawawalan ng partner. Tama ba yun? Tama kaya yun na reasoning as shown here? What do you think? Because if that is right, if you are able to pair, yun yung tinatawag natin actually kanina na one-to-one correspondence. So we can actually put all the elements here into one-to-one correspondence with the elements of the other set. And if that happens, then walang set dyan na may mas lamang na number of elements. Okay. The point here is, for finite set, iba yung perception natin sa which set has more elements, which set has a lesser number of elements. The properties will change if we are talking about infinite sets or sets that are not finite. We can see here that actually the cardinality of the set of integer is just the same as the cardinality of the set of positive integers. And normally, yung naka-assign na cardinality, nilalagyan na yan natin ng pangalan. Special for the cardinality of the set of positive integers, it's this symbol. Mukha siyang x pero hindi yan x. Subscript niya ay 0. So yes, these two sets are equivalent. Obviously, they are not equal, but they have the same cardinality denoted by this symbol. So hindi dapat tayo malito doon sa elements na wala kay positive integers. Because what we are looking at is the number of elements. Actually, if we are comparing it to another set, it's not the set of positive integers. It's the set of positive integers that are, for example, divisible by 5. So yung elements natin dito, kung divisible by 5 lang dapat, Ang elements natin dito ay 5, 10, 15, 20, 25, 30. If we compare the number of elements, ano yung conclusion natin? Equivalent pa rin ba kung yung set dito ay the numbers, natural numbers that are divisible by 5? What do you think? Anyone? Are you still there? What is your answer if this is the set of all natural numbers divisible by 5? Do we have the same answer? Kaya? The answer is?
Equivalent din po ba, sir, kasi infinite
Yes.
din sila?
Tama. Tama. So,
Okay.
equivalent pa rin. That's correct. That is actually correct. Kahit actually, ang set natin dito ay multiples of 100. So, it becomes 100, 200, 300. It doesn't really matter. We can still map. We can still establish a one-to-one correspondence between the elements of the two sets. And that cardinality is represented still by this one. Okay, we have another pair of infinite sets. We have the set of rational numbers and the set of positive integers. Well, medyo mahirap ito i-comprehend, no? Ilagyan ng abstraction or ng concrete na illustration apart from this one. This is from the book of Raleigh. So yung ginawa niya, nag-devise siya ng paraan para malinya niya, mahilera niya lahat ng elements ng rational numbers. And this is how he did it. So by doing this one, naka-create siya ng systematic na paraan para ilagay sila sa number line. So if we continue, it will include all the possible rational numbers. Kasi ang rational number lang naman ay any ratio of two numbers. Of course, it includes all the integers and fractions. So by doing this, let me repeat that. By doing this one, we are putting it actually all the rational numbers in a number line. So if we put it this way, we can actually map it again to all the elements of the set of positive integers. Therefore, establishing a one-to-one correspondence between the elements of the two sets. So, well, the answer is, again, the two sets are equivalent. They have the same number of, or they have the same cardinality. All right, let's now proceed to other concepts, subsets. So we have a definition here. Is set B, so ang A natin dito ay part ng sentence, hindi set A. So a set B is a subset of a set A denoted by, for the notations, importante yung direction, no? Yung opening, doon normally nakadirect yung mas mataas na set. Yung set na mas may maraming laman. Yung subset, yun yung nasa, dun sa may curve, yung nasa right side. Or, kapag invert natin, then magbabaliktad din yung positions ng A and B. So, that's the symbol for a subset. Anong definition niya? If every element of B, that this is the subset, lahat ng element ng subset, dapat element din ng set A. The notations this one, these notations that we can see here, this is used actually if the subset is a proper subset. Later on, I think andito pala. What are proper subsets? First, we define an improper subset. If A is any set, then A is the improper subset of A. Because for any given set, itself is considered a subset. Because all elements of it is an elements of A. Medyo nakakatawa, pero dinidiscuss talaga, no? For any given set, itself is a subset. Specifically, it's termed as improper subset. So, isa lang yung improper subset ng kahit anong set. Yung sarili niya. Yun yung sinasabi natin dito. Any other subset, apart from the improper set, is considered a proper subset. Normally, doon natin nilalagay itong symbol na ito. Wala yung equal sign sa baba. For improper subset, doon natin nilalagay. By the way, kapag baliktad, how do we read this one? B is a subset of A, pwede pa rin. Pero if we start reading from the mother set, ano na nga yung meron ba? Mother set. So anyways, ano yung note natin dito? Note that according to this definition, for any set A itself, and by the way, merong dalawang special na subset, no, of any given set. The improper subset, which is itself, and of course the null set. So automatic na subsets ang mga apart from the proper subsets. Normally, itong dalawang subsets na ito, itself and the null set, are also called the trivial subsets. Another definition, power set, denoted by P of A. So if you are given set A, the power set is denoted by P of A, and this is defined as the set containing all the possible subsets of A, including, of course, the set itself in the null set. So it's a set containing sets. So halimbawa, if this is the given set, it's the set containing 1, 2, and 3. The improper subset is the set itself. Kaya 1, 2, 3 pa rin yung nakikita natin dyan. Yung mga proper subsets, it's the set containing this one. So madami. So pwedeng singleton, a set or a unit set, meaning it's a subset containing one element, of course coming from set A, or two elements. Yung 3 elements, siya mismo yon, and then of course kasama si null set. If we're going to write it as a power set of A, de ganyan lang. I-collect lang natin yung improper at saka proper subsets. So how many subsets in all does this set have? 1, 2, 3, 4, 5, 6, 7, 8. Actually, we have a formula for identifying the cardinality or the number of elements of a power set. That is simply 2 raised to n. N here is corresponding to the number of elements of the given set. So halimbawa dito, that's 2 raised to 3. That's 2 raised to 3. Tama ba? And 2 raised to 3 is 8. Kaya 8 yung nabilang natin na elements ng subset. Pero kay set B, because there are more elements, there are actually 5, well, of course, we expect a power set containing more sets, more elements. Specifically, there will be 32 different subsets na laman ng power set ng B. Okay. Now, next here is set operation. So, when we discuss set operation, we actually discuss the 4. We have intersection, union, complement, and the set difference. So we are operating on sets. Hindi numbers, pero set. We start with intersection. Here is the definition. The intersection of sets A and B, denoted by that symbol, is the set of all elements common to both A and B. By notation, A union B is the set of all X such that X is element of A, and we take note the word and, X element, X is an element of set B. So, kailangan yung X present to both sets. We have an example here. So, A is this set and B is this set. If we're going to take their intersection, we simply take at what is common to both of the sets. So, that's the elements 4 and 5. That's why the answer is, the union is the set containing 4 and 5. Set A and C have no common elements. That's why we write A intersection C equal to 0. Uh, equal to the null set B. Because wala nga namang common dyan. 1, 4, 5, 7 at saka 3, 6, 9. That's set intersection of two sets. Union is a combination. It's the set formed by combining all the elements of two or more sets. But if we speak only between two sets, then the definition of union is the set containing all the elements that belong to A or to B or to both. Take note again of the notations that we are using here. A union B is the set of all X such that X is an element of set A, and the term that was used here is the word or X is an element of set B. Kanina sa intersection it's and, but this time it's or. I think these are the same set. We're going to take the union of A and B and the union of A and C. So A union B and A union C. So ito yung sagot. This is the union. You notice that 4 is present to both. But in the result, we all, of course, write it only once. We do not have to write it twice kasi present siya sa dalawa. Distinct dapat yung elements sa set natin para hindi pa ulit-ulit. A union C, it's the same principle. We combine all the elements. If it's common, we write it once. This is the third set operation. It's the set difference. We have two notations here. Hindi siya slash baliktad. It's read as A minus B. Or sometimes we use the notation for the ordinary subtraction. And by definition, this is the set collection of all X such that X is an element of A and X is not an element of B. So we need to satisfy these two conditions here. So first, we look at the first set given because in the first question here, we are solving for A minus B. So considering A, ibawas natin lahat yung mga common, meaning the elements that are common to both. Tapos kung ano yung maiwan, that's actually the result. So the common between the two sets are 2, 4 only. So if we remove 2 and 4, what remains is 1, 3, 5. Well, of course, majority of the objects that we have in mathematics, subtraction is not, most of the time, not transitive. Anong ibig sabihin natin doon? A minus B is not the same as B minus A. So even for set difference, that's true. B minus A is, of course, the same, a different set. So we consider B. Well, of course, the intersection or the common elements is just the same, 2 and 4. So kung madrop ang 2 and 4, 6 and 8 na lang yung maiwan. That's B minus A. And of course, complement. Hindi yata consistent yung notation ko dito, but I believe they are accepted. A prime or A, ang superscript niya ay si C, letter C. That's read as A complement. That's still A complement. Ano yung complement ng isang set? We are actually basing it to the universal set or the universe of this course. So doon natin binibase. How do we do it? We collect all the elements that are present in the universal set but are not present dapat in A. So we are negating. So this is actually the same as the difference of the universal set and A. U minus A is the same as A complement. So this is the answer. Ganun din sa ibang questions. What is the complement of A, B, C, D? And here are the answers. I'm going to post siguro this slides later on so that you can go over with the following. Okay, let's now proceed to another topic, which is normally a topic that comes after discussing sets. So the reason why we are discussing sets because we are discussing relations. Ang susunod dito, functions. So the reason why we are discussing relation because they are needed in defining a function. Mga ganon. Hanggang sa papunta tayo doon sa talagang gusto nating maintindihan. Relations, where do we start so that we could understand the concept of a relation? We need to understand the concept of a cross product or the Cartesian product of two sets. Another definition, the Cartesian product of A and B is denoted by A cross B, that is read as A cross B, and it's a set. Okay, so makikita natin na ang definition niya ay set. Isa siyang set. Such that, or ano yung elements, if we look at the elements, hindi lang siya basta number, but it's actually a pair of two numbers. We normally call that ordered pairs. Saan natin kukunin itong A? What is A? This is a representation of any element from set A na given dapat. Ganun din kay B. B should be an element of the set B. Let's provide some examples. So let's start with finite sets muna before we proceed to infinite sets. Suppose the given two sets here are A and B, and we can see their elements. For A, we have 3. We have 2, 3, 4. Yun yung elements. For set B naman, we have 4 and 5. Let's build the cross product. Wala pa tayo sa relation. Cross product pa lang yung dinidiscuss natin dito. So the cross product is any ordered pair such that for that ordered pair, yung first element dapat or the first coordinate or the x coordinate pag functions pag nasa algebra tayo, dapat nanggaling siya sa first na set. So importante yung direction because this is a cross product from A to B, from A and B. So all the possible combinations here are included in the cross product. Since there are 3 elements here and 2 elements here, the number of possible pairing should be 6. 3 times 2 is 6. That's why we can count 1, 2, 3, 4, 5, 6 na ordered pairs. Another example, we are simply given different sets. Sets C and D. So for set C, 4 yung laman. D, 3. So if we are to count the number of ordered pair dapat na nandyan, there should be 12. So there are exactly 12 ordered pairs there. The first pair is 1, 2. The last pair is 7, 5. Note that for cross products, yun yung formula kung bakit alam natin yung number of ordered pairs or number of elements ng cross product na yan. Now, how about the cross product of infinite set? Halimbawa, ang set na pinag-uusapan natin is the set of real numbers. Well, there are infinitely many real numbers. Tapos, yung isa pang set ay siya mismo. Hindi katulad kanina na normally magkaiba yung cardinality ng A and B o yung dalawang set. na pinag-uusapan dito, parehas na set of real numbers, meaning parehas na infinite set. How can we imagine ba the cross product? And how do we write it? Are we going to write it as a set? Pwede naman. And then we make use of ellipses to denote that it's infinitely many. Pero ang hirap, no? Where should we start? Should we start with the pair 1, 2, tapos 1 half, 1 4, tapos biglang pi e? This is precisely, if we're going to write in it in a set, ang hirap kasi i-imagine. That's why mathematicians developed this one, invented actually, the Cartesian coordinate plane. So all space here is an element of the cross product. Of course, this is extending indefinitely the Cartesian plane. All space there, any point here represents a point or ordered pair that is an element of the cross product. Ibig sabihin, wala pa pala. Hindi pa natin dinidefine yung relation. Ito na ang definition ng relation. Bakit kailangan nating i-discuss ang cross product na galing sa dalawang sets? Kasi naka-base doon ang definition na naman ngayon ng isa pang mathematical object na tinatawag natin na relation. A relation is any subset of A cross B. More particularly, we call it a binary relation from A to B. So ano na ulit yung A cross B? It's a set containing a lot of ordered pairs, especially if the sets A and B have a lot of elements. So kung kumuha ka lang ng subset, most probably a proper subset of A cross B, that subset, so that is a set, that is a collection of ordered pairs. Yung collection of ordered pairs na yon, as long as it's a subset of this one, it is already considered a relation from A to B. For example, by the way, another notation pala related to this one. So if we are given an ordered pair, xy, that is in A cross B, then x is related to y by r. The relation is represented by this one and written as this way. If and only if the ordered pair is an element of R. Here is another term. What do we mean by domain? Yung domain, that is the set of all A. So we have the relation, no? Relation R. If we're going to collect or the first order or the first coordinates and put it as a set, then that is called the domain of the relation. Codomain naman ay yung B. It's the second set used in defining the cross product and then the relation. Range is different from codomain. Maraming nalilito kung ano yung diferensya niyan. But the range is simply the collection of all elements that has a pair. So parang ito yung collection mo ng this time the second coordinate. Kung yung sa domain, that is the collection of all numbers na ginamit na first coordinate doon sa lahat ng ordered pairs na laman ng relation na pinag-uusapan. Si range naman, in yung mga y, kumbaga, or the second coordinates, or the second number in each ordered pair na merong pair. That is the range. So, ang codomain sometimes is exactly the same as range. But also, sometimes, yung codomain is not exactly the same as the range. Mas maliit yung cardinality ng range kaysa sa codomain. Example, we have two sets here. We again work with finite sets. So the cross product is given here. I believe these are the same examples as provided kanina. So if we take any subset of this cross product, then it is considered a relation from A to B. So halimbawa, this is the first relation. So is this a subset of A cross B? We check. Dapat ang 2, 4, there are actually two ordered pairs, two elements. If we check that these two elements are elements of the cross product na basis natin, then we say it's a relation. So 2 and 4, it's actually the first element in the cross product. We also have 3 and 5 present yan. So the answer of course is yes. It's R1 is a relation from A to B. Not B to A, but specifically from A to B. Another subset, but we check if it's indeed a subset of A cross B. Bakit? 5, 4. Meron bang 5, 4 dito? Wala. 4, 5 ang meron. Pero yung nakalagay dito ay the ordered pair, 5, 4. So, the answer is no. It's not a relation from A to B. It's a relation siguro of from some set to another, but we do not know what set that is. No, it's not a relation from A to B. R3 is the null set. Well, is this a subset of A cross B? Yes, because the null sets and the null set is an automatic subset of any set. Okay, let's another example, but this involves infinite sets. So we're going to define a relation from R to R. So yung dalawang set natin ay infinite, tapos parehas sila. So kumbaga, ito yung A natin at ito yung B na taon na parehas lang sila na set. So, before we are to define a relation from R to R, then we have to have an idea muna of the cross product kasi it's from the cross product that we define a relation para makakuha tayo ng subset. So, dapat alam natin muna ang R cross R. So, what is R cross R? It's the collection of all points x, y, such that x is element of the set of real numbers and also y is an element of the set of real numbers. Ito yung sinasabi natin kanina between whether to use set builder or the roster method. We are already talking about infinite sets here, and it's not really helpful to be using the roster method. So this is a more general way of writing it, a more elegant way of writing it, expressing the idea. So what is a relation? It's any set, it's any actually subset, it's any set, a collection of ordered pairs, basta x and y ay element ng real number or ay real number kung diretso. Yeah. So, if we list up any point here, so maaaring tatlong points, 1, 2, 3, may point dyan, and then we put it as a set, yung mga ordered pairs na yon, then that is actually considered a relation from R to R. By the way, if the two sets na pinagkuhanan natin ng cross product ay parehas, sometimes we do not say R to R, no? A relation from R to R, although pwede naman. Pero kung parehas lang na set yan, ang term natin, a relation on R. A relation on R. That means, yung domain ay manggagaling sa R at ang codomain ay manggagaling pa rin sa the same na set R. So, if you hear me saying that, that means parehas kasi yung mapping natin, yung sets na minamap natin. Okay, let's tell whether it's a relation from R to R or a relation on R. So G is the set of ordered pairs x, y such that they are equal. So ilalagay lang natin siya sa listahan, sa list, kung una, ordered pair kung saan ang x and y ay element ng R, and pangalawang condition, dapat equal yung dalawang number. So I hope we can imagine if we are going to list all the elements here using the roster method at hindi set builder, ano yung makikita natin dito? ordered pair 1, 1, ordered pair 2, 2, ordered pair 1 half, 1 half, ordered pair pi and pi, ordered pair negative 2.5 and negative 2. And all. Kaya medyo pangit pag ganun, no? Mas magandang ganito pa rin yung pagkasulat. Yes, G is a relation from R to R. Bakit? Kasi subset naman siya ng R cross R. We are sure na lahat ng mga ordered pairs na sinabi ko na yun kanina ay laman makikita natin sa cross product na R or R cross R, yes. Dahil equal sila, parang binigyan sila ng special si G. Special name. It's called the equality relation on R. Ayun yung term. On R. Meaning, it's a mapping. We are mapping elements from R to R. And it's called equality kasi ang X and Y ay equal. How about this one? On R pa rin siya. So, it's a mapping from R to R. Yung ordered pairs, ibig sabihin, dapat yung numbers dyan sa lahat ng ordered pairs, element ng real numbers. At the same time, dapat meron silang, ito yung relation. Ang Y ay cube dapat ng X. So for example, what is a specific ordered pair that we can provide as an example for this? Pwedeng 2, 8. The ordered pair 2, 8 is included here, is an element of H because 8 is 8. Parang iyon yung value ng Y is actually the cube of 2, which is the value of X. That's only one of the possible elements of this relation. How about this one? This relation, this possible relation, we are not sure yet, is written using the roster method. So, infinite pa rin siya kasi may ellipsis dito. Pero on R pa rin siya. Is this a relation? The answer is no, because we can identify an ordered pair there that can never be found sa R cross R. Because this is 4 and I. This is not already a real number. I is not a real number. It's outside the grasp of R cross R. So now, yeah, I think that's the end of relations. We also have the concept of functions. Function is just actually a special type of relation, but it's better to use the definition here. Let me read the definition. A function p mapping x into y, so x and y here are sets, is a relation between x and y with the property that each x element of the set x appears as the first member of exactly one ordered pair xy in phi. Such function is called a map or mapping of x into y. We write phi tapos colon x to y and express the ordered pair xy element of phi by phi of x equal to y. The domain of phi is the set of all x and the set of y is the codomain of. So the same yung definition natin dun sa relation kanina. And why is that the same? Kasi ang function lang naman is a special type na of a relation. The range is actually ano yung range? The set of all phi of x such that x is the element, an element of the set x. We have an alternative definition dito. My purpose of putting this one is perhaps you might understand the definition better in some of the definitions of other authors. A function phi from set x to y is a relation that satisfies the following two properties. Naka-itemize lang yan. First, for every element x in set x, there is an element y in set y such that the ordered pair xy is an element of phi. And second condition, for all elements x in set x and y in z in y, set y, if the ordered pair xy is an element of phi and the ordered pair xz is an element of phi, then y is equal to z. But I think this is better. This is the an interpretation of the definition. A function is just a special relation, special in the sense that each member of the domain is paired with a unique element in the codomain. Now, to illustrate this one, I have examples here. We start muna with finite sets. So, ito yung first set natin, and this is our codomain, the second set. Well, hindi siya nakalagay as ordered pair, pero nakalagay siya as a mapping. A relation can also be expressed this way. Now, we are going to identify now whether the mapping is considered a function, a mere relation, or not even a relation at all. Nakalagay na dyan yung sagot. It's a grade function. It's a function. Why? Because, bakit nga ulit? If we look at this, each member of the domain is paired with a unique element. So, dapat yung nasa domain natin, ano yung domain? We are pertaining to this first set. Lahat ng elements dyan, unique. Anong ibig sabihin ng unique? Isa. Isa lang. Ang kanilang pair. So, ilan yung pair ni Alice? It's A, it's 1. Bob, so grade ang mga to, A, B, C, D, F, tapos pangalan ng tao. Isa naman yung grade ni Bob, hindi dalawa. Chris, the same. Dave and Emma, pareha silang tig-isa. Wala tayong pakialam kung dalawang tao ang may grade ng D. Ang tinitignan natin, lahat ng elements sa domain ay unique yung kanilang pair. And that happens here. So, whatever this mapping is, it's considered a function. Relation na, function na relation. Let's have another example. Still a pairing of something, two sets, elements of two sets, but this is not considered anymore a function because we are saying that Bob is part of the domain, but he actually does not have a grade. So, hindi siya function. Dapat may grade pa rin yun dapat. How about this one? It's not a function because although all of them has a pair, if we look at it, not all of them has a unique pair. Actually, if this is still grades, this is confusing kasi dalawa yung kanyang grade, yung dalawang grade ni Alice. Alice have two grades, A and B. Hindi na unique yung pair ni Alice. There are actually two. Wala tayong pakialam kay B having been paired with Alice, Bob, and Chris. Actually, hindi natin tinitignan yung codomain kapag function yung pinag-uusapan natin. It's actually the domain that is our focus. Okay, other terminology. So, this circle represents our codomain and this is our range. Codomain, sorry. The function is represented this way because what we are interested is the mapping. The mapping of the elements here to the elements of this set. So halimbawa that is a specific element and map to 4. So 4.3 nakamap kay 4. Ang notation natin dyan, f of 4.3 is equal to 4. So the value of 4.3 in this function is 4. Yeah, that's domain and codomain. That's the pre-image of 4. So if we are referring to 4.3, we say 4.3 is the pre-image of 4. Or if we are referring to 4, we say that 4 is the image of 4.3. So yung nasa codomain, image sila ng nasa domain. Pero yung mga nasa domain, pre-images sila nung nasa codomain. That's why yung arrow natin from the domain to directed to the codomain. domain. All right. So I have here mappings. We are going to tell if it is a function or a relation. So I hope you're ready again with your chat box. Para mas madali, F or R na lang. F or R. F if it's a function, and R if it's just a relation. First one, yeah, relation. That's not a function. Obviously, walang partner si E. Number 2, function. Tama? Yun lang pala. Another concept, types of functions na tayo. Meron tayong one-to-one, injective, onto, surjective, and both. So kung yung function ay both one-to-one and onto, yun yung tinatawag natin na bijection. But what do we mean muna by a one-to-one function? So function siya, meaning lahat ng nasa domain natin has a unique pair. But if we add a property, an observation, additional observation, so function siya at the same time. So the function, the name of the function is phi. Ang dalawang sets na involved dyan ay x and y. So from x to y, phi is a one-to-one function if, ano na nga ito, phi of x of 1, the value of, so x sub 1 and x sub 2 here are elements of x. Galing yan sa domain. If we trace their images, yun yung sinasabi ng phi of x sub 1, ang value ng x sub 1 sa function na phi. When we trace these two values here, their images mismo, yung images, these are images, and if it happens that these two numbers here, x sub 1 and x sub 2 are the same, then onto yan. It's an onto, one-to-one function. Ano bang bawal dito? All elements in the range. So with that definition, how do we interpret it for easier understanding? Tinitignan na natin ngayon ang codomain or specifically the range. So if there is an element in the range that has more than one pre-image, then the function is not considered a one-to-one. It's just a function but it's not one-to-one. So halimbawa ito, if this is a function, is this a function? Lahat may map, tapos unique. Yes, it's a function. Now we identify further if it is a one-to-one function. So titignan natin yung range. So by the way, ano yung range? Ang codomain ay 1, 2, 3, 4, 5. There are 5 elements in the codomain. But if the range is what's being asked, the elements of the range, there are only 4. Kasi sila yung may actual na 3 image. 1, 2, 4, and 5. Now we need to check that for each of them, for each of those elements in the range, there's only one pre-image. For example, 1, the element 1 in the range, ilan ba ang kanyang pre-image? It's A. Isa lang naman. Ganun din ba kay 2? Yes. Ganun din ba kay 4 and 5? The answers are yes and yes. So, yes, this is a one-to-one function. Another example. Is this a function? I-check muna natin, baka nagkamali ako eh. Kasi kung hindi siya function, then what's the point of identifying whether it's one-to-one? I believe it's a function. But is it one-to-one? So the range is the set containing 1, 2, at saka 5. So tatlo yung i-check natin. Check tayo kay 1. Pero pagpunta natin kay 2, we notice that there are two pre-images. It's E and O. Yun yung nakamap kay 2. So ano yung sagot dyan? It's not 1-to-1. It's a function though, but it's not a 1-to-1 function. Another type, we have onto. Alternatively, we say surjective. And how about this? This is a very simple definition. Phi from x to y is onto if the range of phi is y. All elements of the range is also the elements of the codomain. Ibig sabihin, walang naiwan sa codomain. Lahat sila ay merong pair. Lahat sila ay merong pre-image. Nakita niyo ba yan? Yan. Okay, examples again. So, i-check natin kung function siya bago natin i-check kung onto. So, function, everything has a pair, it should be unique. 1, 1, 1, 1, 1. Yes, it's function. Is it onto? Ano yung codomain natin? 4. 1, 2, 3, 4. Ano yung range natin? Lahat ba ay may pre-image? If the answer is yes, then we conclude that this is an onto function. This is the codomain and also exactly the same as the range. This is an example of, obviously, of a function. Function ba siya? Yes. But not onto. Bakit? Kasi may naiwan. May laman, may element si codomain na hindi part ng range. Bijective functions, they are both one-to-one and onto. Function siya, one-to-one siya, onto siya. It's called a bijective function. What is the ano yun, the concept or an idea that we know about bijective functions? Kasi why do we seek or question ourselves whether a function is bijective? Kasi once na bijective siya, invertible, any function. Function from four matrices sa linear algebra or sa ordinary algebra na function lang. If we are able to establish that it is a bijective function, we know for sure that there exists an inverse. That's what we mean by an invertible function. So, yun yung consequence kapag mapuprove natin na bijective ang isang function. Okay, so we have here mapping ulit. Our task is to identify the type. So, ano yung sagot natin? Gamitin na lang natin yung injective I, surjective S, B for bijective, and N kung function siya pero wala siyang type. I mean, it's neither one-to-one, onto, or forced bijection. So let's start with the first one. Function naman siya, so S, O, B, or neither end. Number 1 dito, from left muna tayo. Antayin ko yung sabot ninyo. Or pwede yung just answer it 1-to-1, onto, pwede naman. Encode nyo na lang. Number 1, what's the answer? What do you think? Function siya, I think yes. Lahat naman may pair. Tapos unique. Now let's check if it's one-to-one. So, tigi-isa lang na pre-image. Nako, hindi na siya. Pwede. If we look at this element, it has two pre-images. So it cannot be one-to-one. Now let's check if it's onto because it's possible that it's onto even if it's not one-to-one. Compare lang natin yung codomain sa range. So all have a pair. So this is what? Onto. How about the second one? Meron tayong nakikita doon na walang laman. So of course, obviously this cannot be onto. I-check natin kung one-to-one. One-to-one ba siya? Hindi rin. Kasi this element has two pre-images. Is it a function in the first place? So, isang pair, isa. Yes, it's a function, but unfortunately, it's neither one-to-one nor onto. Number 3, function ba siya? Yes. One-to-one ba siya? Dapat iisa yung pre-images. And then, onto ba siya? Yes, kasi lahat ay may pre-images and unique. So, it's a bijection because it's both one-to-one and onto. And this is just one-to-one, not onto. Kasi merong walang pair doon. So, the range is not the same as the codomain. There you have it. Yeah, I think we will skip this one. Ulit-ulit na siya. Ayan. Meron lang not a valid function. Bakit? If you look at A, hindi unique yung kaniyang image. Dalawa, 2 at saka 4. So this is not even a valid function. There's no point of identifying whether it's a one-to-one or an onto function. Okay. Here is another concept still related to functions. Function composition. I-define lang natin. So if f is a function from a to b and another function g from b to c, we define the composition function which is denoted by f of g from a to c. This is the symbol and the meaning for each a element of the set A. How do we provide meaning? Something that we can understand. Parang nag-i-evaluate tayo ng function. So halimbawa, meron kang f of x is equal to x squared. By evaluation, we mean we compute for the specific value of the function at a particular x value. So f of 2 is equal to 4. We evaluated the function f of x equal to x squared. Diba? At x equal to 2. That's what we mean by evaluation. For function composition, instead of just a number, yung nilalagay natin na input ay function mismo. That's what we mean by function compositions. So, this is the notation as mentioned, and let's provide an example. We have here two functions. We named it f of x and then g of x. This is an example, a very basic one from algebra. Basic algebra lang to. If we are asked what is f of g, sometimes we write directly as f of g of x. Ayan, in-evaluate natin ang f, pero yung input natin ay mismong function. It's the input. So how do we do that? Of course, we start from f. F is, asan yung f? X squared minus 1. Yung x, mag-i-input tayo dyan, it's just na, hindi nga lang siya number, but an expression na 3x plus 1. So we have 3x plus 1 quantity squared minus 1. If we simplify this one, the answer is 9x squared plus 6x. This is the value of the function composition. Function compositions are normally not transitive. Meaning, hindi parehas yung sagot kapag binabaliktad natin yung arrangement, yung position ng mga functions na kinocompose natin. So, halimbawa, if the value of f of g is 9x squared plus 6x, we do not assume na g of f is the same. Kasi in the first place, magkaibang function yan. What is g of f? So our main function becomes g and our input function is f of x. So ang base function natin ay 3x plus 1. I-input natin yung f dito sa x na ito. Yan. So i-substitute natin bali ang x squared minus 1. We simplify that. We have 3x squared minus 2. So obviously they have this different answers because they are two different quantities. In abstract algebra, may naka-note dito. In algebra kasi ganyan, we use that symbol for composition. It's not even bold no or shaded kasi ang shaded, that is a dot. That means multiplication. Pero sa abstract algebra, dahil hindi natin pinag-uusapan yung mga ordinary operations like ordinary addition, ordinary subtraction, or ordinary multiplication, minsan pinagdidigit na lang nila ang dalawang functions. And we have to be very alert na this is not multiplication but composition, function composition. Alright, so I guess I'm going to end with this topic. So, saktong mag-aalas 3 na yan after this topic siguro. Modular arithmetic is it's a way different topic from the ones that I just discussed, functions and relations. This is a topic that is normally taken under number theory, but we have to provide a recap, because we'll be using this type of arithmetic of operation. We know how to add, right? Numbers, of course, or combine integers. But what do we mean by modular arithmetic? So it's an arithmetic, we are operating on something, pero it has a different structure or properties when compared to the ordinary operations that we know on numbers. So why is it called clock arithmetic, aka clock arithmetic? Ito yung modular arithmetic. Because it explains the concept. I have a question here that I really want you to participate with. If the question is, so provided the clock, this is an ordinary clock, it's the clock that we use. If the question is, what time is 5 hours after 10? What is your answer? What time is 5 hours after 10? 3. Yes. So parang ang nangyari, 10 plus 5 equals 3. How about this one? What time is 34 hours after 3? What time is 34 hours after 3? Tama, it's 1. Hindi natin alam kung 1. We're not sure. Kailangan natin i-verify later kung AM or PM. Pero 1. The hands of the clock will be pointing at the number 1. Yes. So, what are we really showing here? Bakit ang 3 plus 34 ay hindi lang siya 37? Bakit ang 10 plus 5? If we are under the ordinary operation, edi dapat 15 lang dapat ang sagot. But it's 3. Kasi nakabigay na yung context na we are actually looking at a clock. And the type of arithmetic that you just used here is actually related to providing the remainder when you divide a quantity by a number. For instance, ang ibig sabihin ng 10 plus 5 Sa context na ito ay, yes, kunin mo yung sum ng 10 and 5 which is 15, but you are actually looking at the remainder when divided by 12. 15 divided by 12 is 1, remainder 3. Kasi it's the time that we are looking after. Ano yung time after 5 hours? Ganun din, 3 plus 34 is 1. Because that's the remainder when 3 plus 34, which is by the way 37, when you divide it by 12, that is 3, remainder 1. We are not actually interested of that number 3. Parang yung 3, that's the number of the complete revolution na na-travel ng hands of the clock. But it will stop at 1 kasi may extra pa siya na 1. Remainder 1. What we used here is what we call, or applied here is what we call modular arithmetic. In binotation, we write 10 plus 5 equals 3 mod 12. Yung divisor natin ay 12. Mod because we are doing a modular arithmetic. What if we change clocks? So this time, instead of having 12, naging 10 na lang yung numbers sa clock. And the question is, what is 9 plus 43? From 9, tapos after 43 hours, saan mag-stop yung hands of the clock? It will be at 2. How do we know that? Because that's the remainder when 9 plus 43, which is by the way 52, divided by 10. Saan natin kinuha yung 10? Because there are 10 possible cases or possibilities na maglaland yung hands. So, ganun din dito, 8 plus 2, 0. So, ang 0, it's corresponding actually to 12. 2 to 10. 8 plus 2 is 10. So, from 8, if we wait for another 2 hours, the hands of the clock will land at 10. 0 lang yung nilagay natin dito because we are referring to the remainder. So, 0 and 10 is actually equivalent. Are equivalents, I'm sorry. And ganun din dyan. Let's provide another clock this time. It's not an actual clock na numbers, but this is a clock on the different days in a week. So we start from Sunday, parang 1 ang Monday, 2 ang Tuesday, ganyan. So if we set Sunday as parang 0, no? The first day is Monday, second day is Tuesday, third day is, so iset natin na ganon. What if the question, if today is Tuesday, what day is it after 1,178 days? Yan, ipapasagot ko sa inyo ito. Kindly answer this one right now. We are setting Sunday as 0 or 7, pwede rin. Basta ang 1 natin, ang first day ay magsisimula kay Monday. The question is, if today is Tuesday, what day is it after 1,178 days?